Now we got to the good stuff. Okay. First want to before introduce Michael. For those that don't know who he is, Michael was an automotive engineer for Toyota and General Motors. And his last gig, Toyota lent him to General Motors to run their robotic EV plants. Each plant's about 225 million US. He's running 3 of them. So I said to people that phone me up, if he's smart enough for Toyota and he's smart enough for General Motors, I think he's smart enough for ourselves and Pyrodelta. He's made this invention. The R&D is done. He's been working on it for 8 years. We're done. So he left Toyota last May and he's been working with us. And he's absolutely a brilliant guy. And I just hope he'll invite me when he gets the Nobel Prize, but he probably won't. But I'll let Michael take over because for people that think we're only good in automotives, you're going to be shaking your head when you leave. Say, oh my goodness, these guys have it. And the only thing we've been limited by is the cash we put into it. We don't have a lot of money, so Michael's been doing it all himself, but we anticipate more attention in the not too distant future, which we'll talk about later. And all of a sudden, we go because big companies are phoning up Michael. They won't even go through the head office. They're phoning Michael, figured he'll give up information more than I will. But Michael, are you ready?
Good afternoon, folks. Thank you very much for the kind introduction, Ty. First, I want to start with who we are. We are Pyrodelta, a high-performance thermoelectric generator developer. And for those of you who are not familiar with thermoelectric generators, they are solid-state devices that utilize the difference in heat between both sides to generate DC current. They have been around for a long time, but they were never practical. They were never compatible with any industrial or automotive application, and we made that happen. We are backed by sound engineering and science principles. Everything is verified and tested, and we utilize vertical integration. That means maybe we're not the biggest thermoelectric generator producer in the world, but we are the only thermoelectric generator producer that starts with raw materials, just like Ty mentioned, and make a complete functional module. And throughout our partnership with First Tellurium, now we have a steady supply of this rare mineral. I did not know personally how rare is tellurium until I started needing it for my work. And we encountered difficulty in sourcing this precious material. And thankfully, through our partnership with First Tellurium, now we have an ample supply to keep producing our modules. We are majority owned by First Tellurium, 75%. And what makes us special is that we actually cast the alloy in-house for different applications. I'll speak about that in different slides. Next slide, please. Okay, so let me give you a brief summary of what we've been working on. During the past year, we have custom-built thermoelectric generator systems. We built an emergency generator that works off a butane canister that could be used in disaster-struck areas where you cannot operate a noisy and cumbersome generator. And if you just need a small 200-watt generator that can charge your cell phone or keep a small fridge operating with insulin or any emergency medical supply powered. So we proved that we have the technology to do that. It is very small, compact, and portable. We also managed to produce both forms of thermoelectric generators. We have the flat type, which is pretty well known in the market, but ours is much more robust and much more powerful. And we also produce the tubular form, which is pretty unique. And we are the only ones in the world that can produce thermoelectric generators in a tubular form. What does this mean? That means our thermoelectric tubes, if they are exposed to, let's say, a cold temperature from the outside while you're passing a hot fluid on the inside, this heat differential between the inner wall and the outer wall of the tube is enough to generate DC current. Integrated electronics. So these thermoelectric generators generate a fluctuating DC current And because the thermal difference between the cold side and the hot side is not always constant. So what we developed in-house is a custom-built voltage regulator that takes this power that's generated by these modules, and we make sure it's smooth output 12 DC current. Rapid prototyping, because we control all aspects of manufacturing, we can change any design change very rapidly. We don't deal with contractors or other suppliers that make small bits and pieces for us. We make everything from scratch. Next slide, please. All right, recent milestones. Fully functional prototypes for testing power output under real thermal loads. The recent one was, and I'm very proud of, is our integration of a thermoelectric module that utilizes the heat from a car coolant. As we all know, internal combustion engines are about 28 to 30% efficient. The rest is just waste heat. Now, 29% or 30% of this waste heat is going through your radiator from your coolant. It's actually more than the exhaust. So what we did is that we routed the coolant through our thermoelectric generators, and we managed to generate 12.5 volts that powers the battery. So we were powering the battery with our thermoelectric generators, not the alternator. We have driven our vehicle for 1,100 kilometers without an alternator, and the battery kept topped off with our thermoelectric generators. During the cold start, we do have a capacitor bank that keeps the battery charged until the coolant is up to temperature, and then it is self-sustained. We currently have an active discussion with automotive and heat pump sectors. We think automotive and heat pumps are the low-hanging fruit. Our modules really shine in these two applications. Next slide, please. And this picture is our core technology. We have custom alloy thermoelectric generator materials cast in-house. And what this allows us is that there is different classes of these thermoelectric generators. So let's say, for example, you increase the amount of tellurium and you reduce the amount of antimony, and the material just works perfect in the range of, let's say, 40C to 20C. But if you change these ratios of the materials used in the alloy, you can use them for higher temperatures or even lower temperatures. So the ability to change the ratio of elements in these alloys give us a very big degree of freedom to design whatever thermoelectric generator that our clients need and be able to provide a custom solution for their specific application. Next slide, please. All right, so the strategic focus. Short term, we are focused on automotive heat recovery and high efficiency and residential heat pumps. And when it comes to automotive applications, I believe internal combustion engine vehicles aren't disappearing overnight. So despite the push towards electrifications, millions of internal combustion engines are still on the road and will be for decades, in my opinion. Global infrastructure and affordability continue to favor internal combustion engines in many regions in the world. So what we're doing basically is that we're bridging the gap to EVs. And while the world transitions to electric vehicles, thermoelectric generators offer a practical, immediate way to reduce the environmental impact of internal combustion engines without waiting for full electric vehicle adoption. Also, hybrid system benefit. Many hybrid vehicles still rely on combustion engines, integrating thermoelectric generators into these platforms deliver performance and sustainability without major redesigns. And major redesigns is something automotive companies are very sensitive to, because they have these production plans like Ty mentioned. They are $200 million, $300 million with robotic systems and production lines. And if you bring anything to change that, even if it's a good idea, and that means they are going to change this substantial investment, they become very sensitive to that. So it's very important that we develop something that integrate into existing vehicles without changing that for them to be receptive to the idea. And we succeeded in that. We are not competing with electric vehicles. We are facilitating the transition. Pyrodelta supports cleaner future by optimizing what we have now, while the EV ecosystems continue to grow and mature. So this is for short term. We're also interested in heat pumps. We think our tubes that we showed in the previous slide can be put in an array. These tubes, once powered, actually they work in reverse. So you can use them as thermoelectric generators, or you can use them as heat pumps, actually. So if you supply them with DC current, let's say it's coming from solar or any other power source, you can actually have very cool air coming out of them without compressors, without any moving parts, without changing oils, without even noise. So that's a game changer in terms of cooling and heating. For long term, we are looking to build scalable off-grid energy modules. So we are looking to integrate our modules and put them in series and actually produce a large amount of energy that sustain several buildings off-grid. And we put everything in a 20-foot container. So we make sure that this is easily can be transported anywhere. And we also looking into emerging markets like marine and aerospace, specifically drones. We think we can integrate our modules into drones because they have no moving parts. They can benefit from waste heat and increase the efficiency and the airtime for these vehicles. Next slide, please. Okay, competitive advantage. Excuse me. The fully in-house material and casting process, I think this is very special because most of the thermoelectric manufacturers, they have different suppliers and different factories that they build these things in stages. So they have a foundry that they use, and then they have another facility to cut the material after it's been casted, and then they have an assembly plant. For us, we do everything in-house thanks to our industrial process that's patented in Canada and the United States. We can build flex form factors. So like I mentioned, plates and tubes, and even custom. So that means if a customer approached us and they want to install these thermoelectric generators around a chimney of a cement plant, for example, that's absolutely possible. We can do an on-site visit for assessment, and we take measurements and we start designing around that. And this is something that nobody else can provide right now for large industrial settings. Lower material costs versus legacy tech. Like I mentioned, our process is very efficient. That's what makes us special, and we protected our IP rights by patent. And our compact power output from untapped heat sources, like if you have a stream of cold water on your property, or you have a well, or you have heat difference in any part of your workplace or your balcony or anywhere, if you have ice on the top of your roof, we can use that. So actually ice on the top of these modules will make them work even better. Next slide. Market potential. So right now, the tech market growth forecast is $800 million. And this is going to grow much more if the thermoelectric generators are actually more viable. So because of our design, more companies, more industrial plants will actually consider thermoelectric generators in their setting and their processes. So we have strong tailwind in energy efficiency and electrification. So the target sectors, like I mentioned, is automotive, EV range extenders. This is also something very important for those of you who don't know. EVs generate a lot of heat. These batteries heat up, and we need to cool them as you drive your EV. And we can use this hot air to actually recharge your batteries to some degree. Heat pumps. This is also very important. Most of the energy that we use is just to cool or heat our houses. And if you have a solid state compact solution, even built into residential homes, that could be a game changer in terms of climate control, and as well as industry energy systems. Next slide, please.
All right, that's where I come in here. Thank you, Michael. I just want to mention a few people here that we talk about data centers. Michael talks about data centers. It's exact same application for crypto mining. So when you see data centers, think crypto mining if that's what you're looking for. Potential government and industrial support when it comes to funding. As people in this room know, I think they all know that we hired a firm out of the Middle East 2 months ago to make introductions to people that obviously have a lot of money, but also want to work in the world of energy. So, people are making interesting phone calls to myself and seeing what's going on. They're just not used to a small company saying, well, hold on a sec, you're not the only game in town, so to speak, because we anticipate that with all the government funding that's coming available to energy companies, whether automobile, greenhouses, solar, there's opportunities from governments. And one thing we should have mentioned, I'm not sure if we did, is that some of the applications we talked about last year, greenhouses, where you can save a farmer 30% on his cost, but also solar. We mentioned that tellurium is used by First Solar in their panels. But as Michael has said, is that we can also use our Pyrodelta application at nighttime in the dark to help with the economics of the solar panel. So, and that can be used on anyone. It doesn't have to be on the First Solar. It can be used on anyone that uses this, has solar, that they can use our stuff. So obviously, if you can get some benefits at nighttime, it sort of adds to it. And the interesting thing I should point out to people is that we mentioned AI data centers and crypto mining, and they started reaching out to us because we were focused on this automobile. Michael can only work on one main thing at a time. And the reason they reached out to us is that the USA Today newspaper, we all know who they are, did a feature story on Pyrodelta and Michael on December 11th or December 12th last year, so six months ago. So I don't know how many people have been involved with a junior company where USA Today does a feature on you. I know I've been around 40 years. I don't know of any, but I'm not saying we're the only one, but it's very few to say the least. And because of that, people started seeing the videos and comments, oh my goodness, these guys can handle 900 degrees centigrade. That's 1600 to people that went to school when I did, 1600 Fahrenheit. And to put in perspective, we were telling people, and I've said I'm not the brightest guy in the room sometimes, so it takes a while to kick in. But we're telling people that, the average competitor, it gets up to 150 degrees centigrade, maybe 200. It starts melting, it starts cracking. That's why they can't do the stuff with the automobiles, with the cement plants, with the AI data centers. So finally, we put out a video. It's on our website. We're going to put it here today, but I figure one video is enough, especially if I'm in charge. It'd screw it up. And just say, here's our thing at 900 degrees centigrade. The flame's right at it. Boom, you can see it working, no problem. We brought one off of the shelf. I don't know, one of the Home Depot or wherever it was, brought one off the shelf, opened it up to show people what they do, and put it beside the gun, not even with the flame at it, just put it beside the gun, melt it between 5 to 10 seconds. So you don't have to believe us, you can see it with your own eyes. That's why the big boys are calling up and they're saying, okay, how can we get involved, and so on and so forth. So we have an opportunity here to say, what are the energy potentials that we can do? Cars, obviously. And what Michael said, just to put things in perspective, in the USA Today article, Michael was quoted as saying this, and I'll preface it. When Michael approached me a year and a half ago to get involved with this, being an automotive engineer, he said to me, if you can have a device that saves 0.5% to 1% in fuel savings and all that, every major automotive company will be knocking on your door. So in the USA Today article in December, Michael's quote is saying he believes we'll have at least a 6% advantage. And I say to people, Michael's a bright guy. It's probably a little higher than 6, but let's just pick a number out of the air. Let's say Michael would have said 8%. I'm not saying that's the number, but let's just say he said it, and it only got to 7.5%. There'd be people on the internet saying these guys are a bunch of liars. They said it was 8%. They only got 7.5%, as opposed to we were looking for half to 1%. So we do things differently. We keep it quiet. When we have people wanting to do a deal, we wait for it to be 100%, not 99%. And that's the thing, as I say to people in this room now, is that when we sold Quinto, I'm telling people saying you got to drill here, you got to drill there, you got great property. We halted it on a Sunday night. So all those people that were saying you got to do this, you got to do that, they missed it because we don't tell people we're dealing with people. And I can tell you now, the people that know me for 40 years, 50 years, Matt, no, we don't, there's no reason for us to BS, right? We do things a little bit slower, but I don't want to have a false start, come back, well, these guys aren't telling the truth. So 6% is what Michael said at the USA Today, and that's what that article's got people in the AI data centers and cryptocurrency calling us up to find out how they can be involved. And I'm smart enough to put on glasses and listen and just nod my head because I don't know what the heck they're talking about. But when Michael explains the stuff, it's good enough for me. Okay, so governments. This is from maybe a month ago, 3 weeks ago. David Eby, Premier BC, fast tracking 20 billion in resource projects, including for energy, right? So, they're specifically looking for, critical metals. We told you we have it. Plus we got the copper porphyry, probably molybdenum porphyry. So do they want to sit there and help move a BC company? Probably, because we don't have to get involved in the tariffs. That's another advantage that we have, but we're flexible. We are going to be we're dealing quasi in the US right now. So I anticipate we may have something in the next 2 weeks, next month, whatever, but it's there because obviously we're not inventing anything new. We're just capturing the heat. And we'll be sending a note to one of the governors down in Mexico to say, how would you like to be our focal point to get into South and Central America and all that? You don't have to deal with tariffs. So I'm agnostic when it comes to who my business partners are, as long as their checks don't bounce. And now we're thinking, to move forward, I've been talking with a lobbyist from Victoria over the last week who's away on holidays. He happens to know the government of British Columbia very well. So haven't hired him yet. So, but we're talking because, one thing we know about politicians, they don't mind giving money away and taking the credit for it. So we think our story is so compelling that, we hit a couple of different angles here. So we think will be of interest. And then I think it was last week, if you read that, or 2 weeks ago, Adrian Dix, BC spending $100 million, giving it to low-income households for better heat pumps. We know we're going to have better heat pumps. No one can compete with us. So haven't had a chance to talk to Mr. Dix. Hopefully, if I get this lobbyist sorted out, they can make the introduction since they're very friendly with each other. Okay, Michael, go ahead.
Thank you, Ty. So what's next for us? Scaling production of application-specific prototypes. I want to touch quickly on the crypto mining and data centers because this is a very important sector for us. As Ty mentioned, we are in active talks about that. So just to explain briefly, these GPUs, these computers are submerged in a dielectric fluid. This dielectric fluid, actually, if you submerge any electronic component in it, it doesn't burn because it doesn't conduct electricity. But what it does is it cools down the components. This liquid is pumped around the GPUs, around these supercomputers, and extract the heat. And the plan is that to have these this heat, this liquid hot fluid go through our through our modules and capture some of this wasted heat and turn it into DC current. Why this is very important? Because some sensors need to be autonomous from the grid. So if you have a very expensive plant running and you just want to measure the temperature, you want to measure the humidity in that facility, and you want to make sure it's autonomous, that means it doesn't depend on the electricity supply to the facility, you will basically put batteries in it, just like your smoke detector, right? But what if we can power that with thermoelectric generators? And that's why they are very interested in our devices, because our devices, if paired with these sensors, can go up to 10, 12 years without even one battery change. So imagine having this reliability without moving parts. Your sensors are logging real data and providing it, autonomously without reliance on the grid. So that's what they're interested in, and that's what we can provide. The second thing is securing IP around casting the tube design. We have developed our product into a ready product that can be purchased. So we are way beyond the R&D phase right now. We have an actual product, and explore licensing and manufacturing partnerships with OEM manufacturers, and as well as exclusivity contracts with data centers and crypto mining facilities. Next slide. So this is the vehicle that I mentioned at the beginning of the presentation. We chose this vehicle because it's an off-road vehicle that enabled us to test our device in the harshest ways possible, just to test it for vibration, will it last, how long it will keep providing, and it passed all these harsh tests. We wanted to make sure that we always over-deliver and provide a real good product that can be relied on for years and years, not just a novelty item, but something that can give our clients real benefits. Next slide. Okay, so the key takeaway is that we are very special in the thermoelectric generator manufacturing world. We are positioned to lead in custom thermoelectric generators. Customers don't have to design their products to fit off-the-shelf components anymore. They can ask us, and we design our thermoelectric generator to fit their existing systems. This exposes us to a large market share, and we can provide real solutions and prototypes pretty fast. Thank you so much, and we welcome your questions and your inputs. If you have any technical questions, please let me know. I will do my best to reply to them without, of course, disclosing any sensitive information about our process. Thank you again.